When I plugged in 0.1, 0.1 gives me the bigger number, so I'm going to put in 1.105 for that. And then x to the third, should I put in 0.1 or negative 0.1? 0.1 is going to give me the, well, yeah, sure, doesn't really matter. And then over 6, and I got 0.000185. That's my max error. This problem is easy.
What?
Yeah.
What's hard?
In terms of error.
What's hard? Where's the hard problem right
In terms of error, this is easy. I don't, it's not worth it.
No, it wasn't 13.
Yeah. I don't know which is harder, 11 or 13, but.
And then it's not going to get hard way.
That's a yes.
So either way, it's on Monday, so.
Let's keep going.
Should we memorize the ocean?
As best as you can, yeah. And you can always like do them yourself. You know, you can always like.
Yeah, but they think you're.
Yeah. I'll tell you, in most multiple choice problems, they're gonna kind of give you the series a little bit, and the open-ended they won't. But then you have 15 minutes, so you
Give
have a
your
little more
example
time.
of multiple choice.
Hmm?
Your example of multiple choice.
I don't have one.
Is this a hard test?
It's gonna be so hard to do.
I thought it was going to be super hard.
I'm really scared for it.
Yeah.
I don't know.
Question.
Monday.
Oh my God! Seriously, just relax. Let me get these out, and then we'll go from there. All right, I have the answers to the stuff from yesterday.
Impossible. Yeah.
There are parts of this that should have been easy, like part A. Well, I guess I don't have to go through here yet.
You can't count.
Part C was kind of crazy.
You just let me come down here. I can, right?
Part C was crazy.
Part C.
Yeah.
Like what?
Yeah, I was kind of confused on part C.
Yeah, it was crazy.
A little bit.
Did everybody finish the packet? Like,
No.
I didn't do
I did parts A and B,
I cried myself to sleep.
and then C made me so sad about myself. And then I just quit.
When Oliver can't get it, then we're just like, a little bit.
okay, let's try to go over this first one. How about? And let's see how that goes. On the test, which I'm sure will be Monday.
Tuesday, you mean? You meant to say
Don't even start.
Thank you so much. I love you.
Monday we start.
There will definitely be an open-ended question
I'm gonna bring you a birthday card tomorrow.
that has some similarities to this one. So here we go. Right up. Okay, part A. Write the third degree Taylor polynomial for f about x equals 2 and use to approximate f of 1.5. Part A, super easy, 3 points, everybody should get it. So we just start following the formula. The Taylor polynomial says take, the first term is f of 2, then the next term is going to be 5, times x minus 2, don't forget this is centered at 2, not at 0, so I have to have that. The second term is going to be 3 times x minus 2 squared over 2 factorial. How many? Third degree, so I go another one. Minus 8, x minus 2 to the third over 3 factorial. Yes.
Do you have to have that verbatim?
No. What did you do?
Well, I had like the step before it and the step after.
That's fine.
What?
Like I plugged
Oh,
it
yeah,
for
first
X. And then before it I had like
Yeah,
just it wasn't as
Well, I say no, but I mean, I should look at it. The x minus 2 is in there, and the
Yeah,
number
I
in
have
here.
that, but
Okay.
just a different step.
Okay, that's fine. And then, so plug in 1.5. This is a calculator problem. And you get that answer, f of 1.5 is approximately negative 4.958. Is that okay? 3 points, that should be pretty easy at this point. If not, that's fine. Okay, part B. Now I say that the error usually isn't that many points. You're only going to find it in an open-ended question. And in this particular test, it was 3 points worth. So, part B. The fourth derivative of f satisfies the inequality that the fourth derivative of x is less than or equal to 3. You might think, like, well, why are they telling you that? We'll get to it. For all x in the closed interval 1.5 to 2. So they're also telling us x is between 1.5 and 2. So 2 things have happened. They told us what x values we're looking at. The reason why is, why did they tell us an interval? What do they want us to pick from that? The maximum x's. They want us to pick, like, probably 2 when we plug stuff into our equation. They want us to pick the thing that's going to give us the biggest error. In the last problem, it was negative 0.1 to 0.1, and we picked 0.1. This time, our interval is this. We're probably going to pick 2. Okay, and they're also telling us the fourth derivative is less than or equal to 3. That's kind of weird, but we'll get to it in a second. Use the Lagrange error bound on the approximation of f of 1.5, found in part A, to explain why f of 1.5 does not equal negative 5. F of 1.5 could equal negative 5. This is an estimate, right? F of 1.5, we only use the first 4 terms of the series to estimate what f of 1.5 is, so this was just a close approximation. Maybe f of 1.5 is negative 5. Maybe. I'm just saying. So it's possible, because we only used a few terms of the series, that this is just an approximation. It's pretty close to negative 5. They're wanting us to show them that it's definitely not actually negative 5. So I use the remainder formula. Okay, start by trying to find the remainder. Well, the remainder says, because I had a third degree, I'm going to use the fourth derivative at some x value. I'm going to do x minus 2 to the fourth, and I'm going to put this all over 4 factorial. Does that make sense, the remainder theorem?
Yeah.
Okay. What the heck are we supposed to do with this? Why did they tell us this? They told us that the fourth derivative is less than or equal to 3, just so we knew what to plug in here. We're going to plug in 3. They're telling us this derivative has to be less than or equal to 3, so telling us the biggest it can be is 3. When I'm trying to find remainders or error, I'm trying to get the biggest amount of possible error. So if the biggest this could be is 3, I'm going to use 3. That's why they gave it to you. Okay? And now here's x minus 2. Well, again, I have to pick an x that gives me the biggest amount. So what x do I want to pick?
1.5.
Yeah, I don't want to pick 2. What happens if I pick 2?
0.
I get 0 on the top, and then 0 to the fourth. The whole thing's 0, and I have a 0 error. That's not good. I want to pick 1.5 instead, because I'm going to take it to the fourth, so, well, I'll get a positive amount, that doesn't really matter, over 4 factorial. That is going to give you,
Why wouldn't you use the rings? Oh, never mind. Never mind.
this is going to give me, I put the plus or minus. I don't know that that's really that important. I put plus or minus because I think when I looked at their answers, they had plus or minus 3 here because the absolute value is less than 3. So I could put 3 in or negative 3. I don't know that they'll take off for that. I won't, but so whatever. And you get plus or minus 0.0078. This is the most error on that interval. This is the most we could be wrong. So, right. So when they are asking us, is it possible that f of 1.5 is actually negative 5? The answer is no. Because my error is this tiny, and if I subtract that from this, if I take negative 4, well, I want to subtract if I want to get closer to negative 5. It's okay, 0.0078. It still is 4.958. get up to negative 5. Yeah.
Okay, so if, how come you,
I know.
no, it's like, why do you have to use the remainder theorem? Why can't you use the other one where it's n plus 1? Because that's what I did, but I got the same answer.
It is n plus 1. Like for this,
Yeah, but isn't n,
n should be the whatever the highest degree was in the series.
okay,
So n is 3. So 3 plus 1 and 3 plus 1.
okay.
Yeah, I did. I just didn't write it. I probably should have written it. Okay?
Now, C.
Alright,
You want 3 decimal places?
I guess, I don't know why I went to 4. You could have just gone to 3 because that would have gotten you the same thing. Okay, this is all on your answer sheet too, so you do have it written there too. Part C.
Would they take off for more than 3 decimal places, or just less?
Just less.
Fewer.
I'm wondering if I did this the too long of a way. Alright, so part C, they want the 4th degree polynomial for f of x squared plus 2 about x equals 0. Oh no, yeah, I gotta go rewrite the whole darn thing. This will be fun, you ready? Okay, so if I'm gonna rewrite this whole Taylor polynomial, I first have to find out what f of x squared plus 2 is, evaluated at x equals 0. So that, at x equals 0, this is f of 2, correct? And what's f of 2? Negative 3. I'm giving it up there. So there's my first number. So, I'm writing this, I'm writing this for g of x. So g of x equals f of x squared plus 2. Now I'm going to get the derivative. So g prime of x is f prime of x squared plus 2. So, well, I'm not write it like that. G prime of x is the derivative of this, right? If I want to take the derivative of this, it's going to be the derivative of f with respect to x squared plus 2 times the derivative of what's inside.
What?
I have to use chain rule. If g of x is defined to be f of x squared plus 2, then the derivative of g is the derivative of f with respect to x squared plus 2 times the derivative of x squared plus 2. All evaluated at x equals 0.
0.
So, yeah, it's going to be 0. So there's my second one. This is g prime. This is g.
This is gross.
Come over here. The second derivative of g is going to be the derivative of this. What do I need to take the derivative of that? Product rule.
And
So I'll take the first term times the derivative of the second plus the second term times the derivative of the first. And the derivative of the first would be the second derivative of x squared plus 2 chain on the derivative of x squared plus 2.
Wow.
All evaluated at x equals 0. Get it? I'm sorry. So this is 0. This is going to be negative 6.
That's not what you had on there.
It's not. I got 10.
Yeah, how about that?
Oh, I messed it up. Oh, how is it 10? Oh, f prime. I'm sorry, I looked at f. Yep, sorry. 10.
What?
It's f prime of. So when I plug in 0, it's f prime of 2, which is 5 times 2.
Yeah, it's probably the worst open-ended problem I've ever seen.
Right?
I say you just skip this test and give us all 100.
The third derivative of g.
Oh,
Give up.
Oh
No.
my gosh.
Okay. That one's
Do you want me
okay.
to stop?
What, is there gonna be a
I
problem?
think
Yes,
it's
yeah.
pressure.
Is there gonna be a problem with this?
I don't know.
How do you do triple product
Yes.
rule?
You don't.
You don't. You put this together. This is before x squared times the second.
But it's just.
She was
Yeah, why must G have a
Oh, don't even, because
crap?
Don't even.
when I finally got G, right? Okay, so when I finally got G of x, the series, after all this work, I got G of x was -3 plus 10x squared over 2 plus 36x to the 4th over 4 factorial. When I finally got G of x, this is, I forgot to set a second question. I finally get G of x. Let me reduce that a little bit. 4 times 3 is 12. Was it 6x to the 4th? Okay,
So then you have to take
this
the
is G of x.
derivative
If
of
they
that.
want to know why must G have a relative min at x equals 0,
You need to take the
That's
derivative
not-
and then
that's not-
take
okay,